It began with a quiet realization that spread through observatories across the world. One by one, scientists noticed that something was happening in deep space that no one could explain. Before long, every major space agency was paying attention to the same mysterious visitor. That visitor was 3I/Atlas, only the third confirmed interstellar object ever observed entering our solar system from another star. At first, astronomers expected it to behave like every other natural object governed by gravity. Instead, it did something that stunned everyone watching. It changed course. Not by a tiny amount that could be dismissed as a measurement error, and not in a subtle way that fit existing theories, but in a manner that appeared to violate everything scientists understood about celestial mechanics. Before we uncover what happened next, take a quick moment to subscribe to the channel. Your support helps us continue bringing you fascinating stories about the greatest mysteries of space, and we're working toward our goal of reaching 1,000 subscribers. Now, let's continue. The discovery immediately drew the attention of the International Asteroid Warning Network, better known as the IAWN, a United Nations-endorsed coalition created for one purpose: detecting and preparing for objects that might threaten life on Earth. The organization brings together some of the world's most advanced observatories, including NASA, the European Space Agency, and China's Purple Mountain Observatory. Throughout its history, the IAWN had focused exclusively on near-Earth asteroids and other debris originating within our own solar system. Interstellar visitors were never part of its mission. Then, in late October 2025, everything changed. The IAWN announced that, for the first time ever, it would begin tracking an object from another star system. Officially, the decision was described as an effort to improve astrometric precision for cometary bodies. To many observers, however, the explanation felt incomplete. Only days before that announcement, 3I/Atlas had disappeared behind the Sun. Independent astronomers expected it to emerge along a perfectly predictable path, one that orbital calculations had forecast well in advance. But when it reappeared, something was wrong. The mathematics no longer matched reality. Its position differed from every prediction generated by NASA's Jet Propulsion Laboratory and the accepted models of orbital mechanics. Among those following the mystery closely was Harvard astrophysicist Avi Loeb, creator of the Loeb scale, which estimates the likelihood that unusual astronomical objects could have artificial origins. Before these events unfolded, Loeb had already assigned 3I/Atlas a score of 4 out of 10, suggesting it deserved closer examination. After the latest anomalies appeared, the IAWN quietly elevated the object to priority status. Suddenly, hundreds of telescopes around the world were redirected toward a single target. The coordinated effort gave the impression that humanity itself was preparing for something no one fully understood. The first detailed warning did not come from a government agency. Instead, it came from a small but respected research collective known as Earth Exists. Its astronomers compared real-time telescope observations with predictions generated by JPL's Horizon system. The results shocked the astronomical community almost overnight. 3I/Atlas was not merely a few hundred kilometers away from its predicted position. It was approximately 1.1 million kilometers off course, a distance roughly 3 times greater than the gap separating Earth and the Moon. Even stranger, the discrepancy was not random. Its distance from observers remained consistent, but its position across the sky had shifted sideways, as though the object had moved laterally through space. That was where the mystery deepened. Astronomers understood that comets can slowly drift forward or backward because of outgassing, the natural process in which jets of vapor escaping the surface create tiny amounts of thrust. Sideways motion, however, was another matter entirely. Nothing in conventional orbital mechanics explained such behavior. Producing that kind of lateral movement would require either an immense external force or some form of controlled internal propulsion. Even Hale-Bopp, the largest comet ever observed in modern times, had never demonstrated anything remotely comparable. Yet somehow, 3I/Atlas appeared to have done exactly that. As speculation intensified, many began asking a simple question. If the object's orbit had truly changed intentionally, surely someone must have noticed before the rest of the world. That question quickly shifted attention toward NASA and the Jet Propulsion Laboratory. Months earlier, in September, NASA's Mars orbiters had been ideally positioned to capture close-range images of 3I/Atlas during its passage near the Sun. Despite that opportunity, no photographs were released. Not one. Officially, internal sources maintained that the imagery was still being analyzed. Others believed there might be another explanation. Some suspected deliberate censorship. If those images revealed unusual structures, unexpected geometry, or patterns of reflected light inconsistent with a natural comet, critics argued there would be every reason to postpone releasing them to the public. Around the same time, Avi Loeb published observations noting that 3I/Atlas displayed an extremely rare feature known as an anti-tail, a stream of material that appeared to point toward the Sun rather than away from it. Such formations occasionally occur because of viewing geometry, but they remain exceptionally uncommon. Then another surprise appeared. Following the object's encounter near Mars, its tail reversed once again, now extending away from the Sun, almost as though the object itself had deliberately changed its orientation. No known natural comet had ever reversed its jet direction with such remarkable precision. The phenomenon only deepened the mystery. And just when scientists believed they had witnessed the strangest part of the story, something even more extraordinary began to unfold. The mystery only deepened in the days that followed. NASA continued to reassure the public that everything they were seeing could be explained by ordinary cometary activity. According to the agency, there was nothing extraordinary about 3I/Atlas. Yet, that explanation raised a question that refused to go away. If the object's behavior was truly routine, then why had the world's asteroid defense network become involved at all? By the end of October, new tracking data finally arrived, and with it came confirmation of what many astronomers had quietly feared from the beginning. The deviation was real. Over the course of just 19 hours, the gap between 3I/Atlas's predicted position and its actual location widened by more than 4 arc minutes, translating into a displacement of hundreds of thousands of kilometers. Orbital specialists quickly began calculating what such a movement would require. Their conclusions were astonishing. To maintain a lateral drift of that magnitude, the object would need to generate a sideways velocity approaching 4 kilometers per second, producing more thrust than many of humanity's own deep space probes were capable of generating. The scientific community immediately split into competing camps. Some researchers argued that the phenomenon could still be explained by outgassing, with jets of vapor acting as natural thrusters. Others suggested that solar wind might somehow be responsible. But there was one problem. Solar wind does not push an object sideways. If the observations were accurate, then 3I/Atlas would require something far more remarkable: a propulsion system capable of sustained acceleration and incredibly precise maneuvering. As debate intensified, the International Asteroid Warning Network found itself at the center of growing attention. Its workshop, organized to train astronomers in tracking unpredictable cometary behavior, filled to capacity within only a few hours, an indication that concern inside the scientific community was rising rapidly. Away from the public spotlight, another development quietly unfolded. NASA's Planetary Defense Office elevated its monitoring status for 3I/Atlas, placing it within the same category normally reserved for potentially hazardous asteroids. The decision puzzled many observers. After all, the mysterious object was moving away from Earth, not toward it. If there was no impact risk, why was it being treated like a threat? To some researchers, the answer seemed obvious. Perhaps the object wasn't finished changing course. That possibility became much harder to dismiss when astronomers witnessed another unexpected event. Just as they began believing the anomaly had stabilized, 3I/Atlas altered its path once again. This time, however, it wasn't a small adjustment. It looked like a deliberate correction. Observatories spread across Chile, Spain, and Japan independently detected the same subtle but unmistakable deflection. Although smaller than the first deviation, it aligned perfectly with the object's original projected trajectory, almost as though 3I/Atlas had intentionally corrected its own course. Nothing about the movement appeared random. Every measurement suggested symmetry, precision, and calculation. To experienced analysts, it resembled the kind of automated navigation correction routinely performed by spacecraft, rather than the unpredictable behavior expected from a natural comet. The significance of the event was impossible to ignore. The IAWN responded by issuing an internal alert labeled Pattern Recognition Event, indicating that the object's behavior matched no known natural phenomenon contained within its observational database. Almost simultaneously, the European Space Operations Center, known as ESOC, transmitted an encrypted update to its partner agencies. According to the report, 3I/Atlas had demonstrated measurable acceleration that could not be explained by gravity alone. In the simplest possible terms, something had accelerated the object. It had fired. The only question remaining was what, exactly, had done it. Seeking answers, astronomers turned the Very Large Telescope in Chile toward the mysterious visitor and carefully examined its infrared emissions. The results introduced yet another layer to the mystery. Instruments recorded a sudden burst of thermal radiation lasting exactly 12 minutes before disappearing completely, leaving behind no lingering heat. The pattern resembled the ignition and shutdown of a carefully controlled engine. Whatever 3I/Atlas truly was, it had now displayed behavior suggesting that it could maneuver under its own power. News of the discovery spread rapidly through the international scientific community. Almost overnight, every major space agency intensified its observations. NASA immediately doubled its monitoring schedule. China brought its U-22 radio array, normally dedicated to supporting lunar missions, back into operation to monitor deep space radio frequencies originating from the object's direction. Meanwhile, the European Space Agency activated emergency procedures through its Planetary Defense Office, protocols normally reserved for situations involving potentially imminent impact events. Official statements insisted that these actions were nothing more than precautionary measures intended to improve international coordination and scientific observation. Behind closed doors, however, many believed the truth was far less reassuring. What officials publicly described as routine observation increasingly looked like something much closer to panic. As the mystery surrounding 3I/Atlas continued to grow, some of the world's leading researchers decided to examine its behavior from an entirely different perspective. Scientists at Caltech and the University of Tokyo began comparing the object's unusual acceleration pattern with the performance characteristics of known artificial propulsion systems. They expected to eliminate possibilities one by one until a natural explanation emerged. Instead, their investigation led them somewhere far more unsettling. The thermal signature produced during the mysterious burst failed to resemble any known chemical propulsion system. It didn't match conventional rocket exhaust, nor did it fit the profile of any existing ion drive. What the data resembled instead was something far more extraordinary. Its heat curve appeared strikingly similar to a magnetohydrodynamic acceleration signature, the type theoretically produced when streams of charged plasma are controlled by powerful electromagnetic fields. It was the same form of propulsion that humanity had discussed for decades as a possible solution for future interstellar travel, but one that remained firmly within the realm of theory. Yet propulsion was only the beginning of the mystery. While researchers focused on the object's movement, another anomaly quietly emerged. The rotation of 3I/Atlas, which had previously remained remarkably stable, suddenly began oscillating in repeating harmonics. Every fluctuation occurred with astonishing consistency, completing a cycle every 247 seconds. Initially, astronomers assumed the object had simply begun tumbling through space. The longer they observed it, however, the less convincing that explanation became. The rhythm was far too perfect. Instead of random motion, the object appeared to be following an organized pattern, almost as though it were communicating through its own rotation. Every new observation deepened the concern inside the International Asteroid Warning Network. What had originally been organized as a scientific collaboration gradually transformed into something that looked increasingly like an international defense operation. Then came another discovery. Analysts noticed that 3I/Atlas was no longer following a trajectory that would carry it harmlessly back into interstellar space. Instead, its corrected course now pointed toward the outer planets. More specifically, the revised trajectory intersected with the orbital path of Jupiter. Calculations suggested that, within only a few months, the mysterious visitor would pass extremely close to the giant planet, entering its vast magnetosphere, a region filled with immense electromagnetic energy. Perhaps it was only a coincidence, but if it wasn't, then the implications became difficult to ignore. The object appeared to be setting up for a gravity assist, the same maneuver human spacecraft routinely perform to gain speed or alter their course by borrowing momentum from a planet's gravity. For many observers, that realization marked a turning point. Global monitoring entered what NASA referred to as Level 3 contingency, a designation reserved for situations in which an object's movement was considered active, deliberate, and increasingly unpredictable. Even so, events continued to grow stranger. Across observatories scattered around the world, engineers began noticing an unusual pattern hidden inside persistent radio interference. The signals arriving at facilities on different continents were no longer random. They had become synchronized. Each interference pulse matched the exact 247-second rotational cycle already observed in 3I/Atlas. To some scientists, it almost seemed as though the planet itself had begun resonating with the object's mysterious signal. Then everything changed. Without warning, every major observatory tracking 3I/Atlas suddenly went dark. Within less than 10 minutes, telemetry feeds from Hawaii, Chile, Italy, and South Africa froze almost simultaneously. NASA's Deep Space Network lost contact completely. Even China's radio arrays, monitoring multiple deep space frequencies, reported total silence. For nearly 47 minutes, no one knew what had happened. Then, as suddenly as the blackout had begun, the data streams returned. Every observatory displayed the same impossible result. 3I/Atlas was gone. It had not exploded. It had not been destroyed. Nor had it simply disappeared behind the sun. It was missing from every known coordinate where it should have existed. Only one thing remained. Across the entire monitoring network, sensitive instruments detected a faint, low-frequency hum. Human ears could not hear it, but scientific equipment measured the signal with remarkable consistency. Every 247 seconds, another pulse appeared. At first, researchers dismissed it as background interference, but the more carefully they examined the data, the more unsettling the pattern became. Each pulse occurred at precisely the same interval as 3I/Atlas's final measured rotation period, almost as though the object had left behind an echo that continued propagating through space long after it had vanished. The International Asteroid Warning Network officially classified the phenomenon as Interstellar Signal Anomaly 2025-11 and immediately placed the findings under restricted access. Despite the secrecy, one remarkable detail eventually found its way into the public. During the mysterious 47-minute blackout, several telescopes had briefly recorded a faint flash of light. The signal was directional, and it aligned perfectly with the orbital path of Jupiter. To those who studied the evidence, one conclusion seemed unavoidable. The object had not disappeared. It had jumped. The hours that followed descended into confusion throughout the global astronomical community. The International Asteroid Warning Network refused to issue a public statement. NASA remained completely silent. China's Deep Space Network released only a single sentence before erasing its observation archives. Tracking anomaly terminated. Object unobservable. For an entire week, no one on Earth knew where 3I/Atlas had gone. Then, late one night, the silence was finally broken. The James Webb Space Telescope detected an incredibly faint flash of reflected light racing through space at what appeared to be an impossible velocity. The mysterious signal streaked across the darkness just beyond the orbit of Jupiter, reopening a mystery that many had already begun to fear would never be solved.